Hey guys, today I will do let's review about the capacitor. Okay. So first of all, give me a sec. Yeah, I wanna say is first of all, capacitor is made it look at that. So for example, this is a simple capacitor, right? It's made it like this. For example, this is a dielectric, and there is a two metal plate here, conductor plate, right? Yeah, what I'm saying is, so this is a general capacitor, right? So this means, as I several times mentioned, with the insulator, it's the same material, but the purpose is different, I said. So that's why in the DC circuit, like for example, this is switching, the R and C here. So when it closes down, look at that, this is time, this is voltage. So it's gonna be like this, if it's 10 volt here, right? So we will say this part is transient, state. So in this part, only this time, the capacitor is gonna be as a conductor, right? So which means the current is following, right? And this part and this part is as a non-conductor, right? It's opposite. So we say in the DC steady state, we will say it's open circuit. The C is, but instead L is in a in DC circuit, in DC state, that time that the inductor is a short circuit, right? Yeah, and move on. This is about the diode, and we will later, if I have a chance, I will mention about power, electronics about. But let's focus on here. Let's see. So look at that. This is diode, just simply diode is, from anode to cathode. It's only one way it could, the current is, follow its own anode to cathode. So since this is AC, it's a waving, right? Plus and minus, right? But only this plus part, for example, it's coming, come past this diode. So that's why this negative part cannot, go this way, cannot. So that's why if we see, we could see only half of a wave, right? As you can see, this is the result when you see the diode, input one diode. But if we, using the capacitor, as a smoothing capacitor, we use it. So since just this is one diode, right? It's gotta be like this. But since we use capacitor, input a capacitor, so it gotta be like this, making smooth, right? Actually, it gotta be, I will check the LED. The waveform is like that. But since we add the capacitor, it makes it smooth. And this is a charge part and discharge part. We say this is simply smoothing, make it smooth, like make it DC. So I'm saying is this is, do you think is DC or AC? This part. The answer is DC. Okay. Yeah. Just simply understand that this part. The capacitor, if we use a capacitor, it could use as a smoothing the voltage. You know what I mean? But inductor we using as a smoothing the current. Different, right? So that's what I'm saying is if you understand the capacitor or inductor, it makes you helpful for understanding the other components. Yeah. And let's see. Where is it? Yeah, and this part I will also explain. Sorry, guys. Yeah, here, look at that. First of all, the jet impedance is R plus reactance, right? But here, as you guys can see, sorry. Yeah, sorry about guys. And as you guys can see, we have to memorize first of all the equation I T C D T D V T. So time goes by, voltage is changing, current is coming through, right? So as I said, I mentioned the DT is omega C, right? J omega, right? And the omega is angular velocity, right? So it could change it to 2 pi f. F is frequency, right? Yeah, that's how we get this formulation, right? And as you can see here, impedance is made it R plus reactance, right? But in this case, R is there isn't, right? So if we multiply J here and J here, so which means JJ is -1, right? So which means impedance is minus J omega C1, right? So minus J is, look at here. Here is a real number, here is imaginary number, imaginary, J and minus J. So capacitors, reactance is, we could indicate in pager here, but inductor is not minus, just J part, right? So inductor is here, this part. And as I mentioned, look at the guys, here is the red line is voltage, right? And this current is a black line. How we recognize lead or lag? Look at that. First of all, compared to peak point, which one is between them? There's 90 degrees, differences because J is, I said before earlier, it's a minus degree. No, 90 degree, right? So which means, now current is black, right? Here, current is lead, right? And voltage is lagging, right? And as you can see here from our formula, we could recognize. So I will delete this first. So V, I, T, C, D, T, D, V, T. If we do differential, what happened? I said this is J omega, right? So which means also the up, front part, it makes it 90 degrees more faster, right? Make it lead. So which means I is leading and voltage is lagging. But instead, the inductor is total reverse. Inductor is V is lagging. V is leading because it's changed this part, right? And I is lagging in inductor. Yeah, kind of confused. Yeah, I'm saying right now. Just try to memorize the equation. Yeah, it's better, to understanding for our part. And look at that. From this equation, as you guys can see here, 2 pi FC, you guys can see here. So which means, reactance here, minus JX is, I said, reactance, right? So reactance is, non-proportional, I mean inversely proportional to the frequency, which means if the frequency is up, which means reactance is gonna be, reverse, which means if it's higher, it means lower. Got it? We could expect it from this equation, right? And the last part is okay. Also, as you see, conductor is actually a battery, right? Conductor. So it's a save energy. How actually you don't need to memorize about this equation. Just save it as electric charging energy. You know what I mean? The unit is joule. This part. Actually, you don't need to know that. But by the way, as I said, the reactance is not real usage, right? For example, I gave you money, you save it, and you return it back. But as I said here, R. So we say reactance is, I mentioned is reactance power, right? It's not actual use or not actual loss. But R, I will say that this is active power. I gave you money, you spent it. So in electrically, you use it, and that loss is indicated by the heat, right? Yeah, this is, we did learn about the capacitor. Yeah. Yeah, thanks a lot. Today lecture is done.